Okay, last problem. We're actually going to do a rotation with the geometer. Notice they tell us to fill out the type, the magnitude, and the direction. Here's how we'll fill that out. First of all, they want to know the type means what type of transformation is it. We've got two transformations we've been talking about today, translations and rotations. This is going to be a rotation because they tell us to. Don't worry about the lady doing announcements. She's not going to distract us. So this is a rotation. How did we know? Because they told us so. Magnitude means how much are we rotating it. Now it's kind of interesting because we can rotate something two directions. We could turn it clockwise, which goes around like this, or we can rotate it counterclockwise. Well, the magnitude, they tell us straight up negative 110 degrees. Now, it doesn't mean that we're measuring anything at a negative angle measure. All that negative means is there's a little secret code in mathematics that tells us which way we're going to go. If they put a negative symbol in front of the magnitude, we are going clockwise. So clockwise means we are going to rotate going this way. We'll put this little arrow to just kind of help our eyes say, yep, we're supposed to go this way. And how did we know clockwise? Because they told us it was negative in the first place. So interesting, type, magnitude, and direction. All right, now let's physically do this thing. So the first thing, they want us to rotate it around this point P right here. So we're gonna take our geometer and we're gonna connect just from point P through one point at a time. We'll start with A. So go ahead, connect through there. And notice we didn't go any further down longer or anything like that. We just started at P. And what we're gonna do is we're gonna put our protractor on there, and it really makes a difference of which way you have your protractor. You could have it face up. Can you tell it's face up because you can read the word the geometer? Or you could flip it over and put it face down. Sometimes we'll have to do that. Here's what we got to do. Anytime we are going clockwise, we need our geometer to be face down. Clockwise is weird. It's negative. Anytime they have it negative, we're just gonna think we gotta have everything upside down. So what we'll do is we'll put the whole of our protractor on top of point P, and see this black arrow right here? We gotta get that lined up with that line that we just extended out longer. So we're gonna rotate this thing around. There we go. We got the hole on top of point P, and that black arrow is on top of that line. Then we've just got to go to 110. I know the numbers are all upside down, but we're going to put a little tick at 110 right there. And then we'll just kind of remove our geometer out of the way, and we'll connect from point P through that little tick mark. This angle right here totally measures 110 degrees. And we went clockwise just because we had our geometer upside down. So it's not like the angle measures a negative amount, it measures a positive amount. Then, because we're gonna do this many other times, we're gonna put whatever letter we just moved, A, we're gonna put that down here in front of this. Cool? All that shows is how we moved 110 degrees this way. The next thing we gotta do is figure out where A prime's gonna be. So we are going to measure with our centimeters. Now, we don't have anything to do with the black line anymore. We're just literally measuring. So we're starting at 0 on this guy, and we're gonna measure how far it is to A. And that looks like that is about 1.2 centimeters or 12, however you wanna call it. We're gonna move on that line that we just made, and we're gonna go 12 little tick marks, and we're gonna call that A prime. So again, we measured this distance, just show them again real quick, just like how did we do that again? We measured the distance from P to A, that was 1.2 centimeters. We're gonna go on that guy and do 1.2 centimeters, and that's where A prime's gonna be. Now, it's just a repeat. We're gonna take our straight edge and connect through B. It's kind of weird because it's gonna be the same line this time. It's not like, so if you drew it again, it's the exact same one that went through A. So we got a 2-for-1 special down there. So now we just measure, and it looks like that is about 2.7-ish, 2.6-ish. So we're gonna go on this guy and measure 2.7 or 2.6-ish. And we'll put ourselves a point, and that's where B prime is. So that was a 2-for-1 special because when we drew that original line, they lined up together. But see, C, he's way off. So we got to start all over. Connect from P through C with your straight edge. And now we got to measure 110 degrees off of that with our geometer upside down because we're going clockwise. If it was counterclockwise, you'd have your geometer right side up. So go to 110. We got our hole on top of point P, black arrow on top of the line that we just made that went through C, and we went to 110 and put a tick mark. Now we'll connect through there. Nice and long. Put a little C down there just to help us. It's like, oh yeah, we're moving C. And now we'll measure this. How far was this puppy? Do it in centimeters or millimeters. It's 2.4 centimeters or 24 millimeters, whatever you want to call it. And then we'll measure that again. And then we'll put our C prime. And then we're gonna repeat the process again for D. We're gonna film it just so you can see. Connect from P through D. Move it 110 degrees. Geometer's gotta be upside down. Hole on top of point P. Black arrow on top of the line you just made. Go to 110, tick mark. Connect. That was D. Then measure how far away is D from that point. It's way out there. And it looks like about 4 or 40, however you want to call it. So we'll go there. Call that D prime, just one left. So connect from P through E. Measure 110 degrees off of that. The geometer's got to be upside down because it's clockwise. If it was counterclockwise, you'd do it face up. So that's the only difference. Connect from P through E. Measure. We're doing this real fast, so don't be afraid to pause the video if you have to see what's going on. Looks like that's at about 1.8-ish. So we'll go about 1.8 on this guy, and we'll put ourselves an E prime. Then, of course, we just did all that work. We've got to very importantly make sure we connect the dots back together correctly so you can look back to the original guy, which is called the pre-image. See how A is connected to B? So that means A prime's got to connect to B prime, so we'll make him nice and fat when you connect them together. And then B is connected to C in the original guy, so we'll go B to C, B prime to C prime, then et cetera, et cetera, et cetera. Connected C prime to D prime, and then keep on going. You can also check, remember that they should be the same size, same shape. This is an isometry, so angle measure was preserved, betweenness was preserved, collinearity and distance, and also orientation this time. We didn't flip him over, it's just a rotation, so 5 things were preserved by this, so they should be the same size, same shape. You're welcome to highlight this if you want to make it a little bit easier to see. It is not an easy process since we've only done one example. In class, we did a couple more from homework together, so feel free to come ask your teacher if you need help. Remember, it was a rotation because they told us so. The magnitude was negative 110 degrees, and that meant we're going clockwise. If it was a positive number, it would be counterclockwise, and we'd use our geometer right side up for positive, going counterclockwise, face down for negative. Let us know if you have any questions, y'all. What a weird question. Have a great one.